Welcome to Tech Teach.
In this class, we will be going with one by one. We will be looking for each of the flip-flops, the characteristic table, and the excitation. So, starting with the first, that is the JK flip-flop. Before that, we will be starting with the SR flip-flop. So, basically, we are having 4 different flip-flops. So, SR flip-flop or SR flip-flop, we will be starting with. So, for each of the flip-flop, we will be finding out what is the characteristics table and excitation table. So this characteristic table is basically used to provide the relation between next state, that is q n plus 1, and the current state, that is q n. So how the next state is related with input and current state is given by the characteristic table. So by using the characteristic table, once we have drawn, then we will be finding out the equation also. What is characteristic equation for each of the flip-flop? Next is excitation table. So in excitation table, basically it provides the relation of different inputs, like how the inputs are there, how the inputs are function of the current state and next state. Current state and the next state. So your current state is like the qn, and the next state is qn plus. So here the excitation table. So excitation table is going to give the relation of inputs. So if a particular flip-flop is there, it is having whatever inputs. So how the inputs are related with respect to the current state and the next state. It is given by the excitation table. So these both the tables are important once we are going to implement a particular flip-flop or a particular sequential circuit by using these flip-flops. Then we will be requiring the excitation table, and also the characteristic table is basically used to show the behavior of the flip-flop. So we have already seen the truth table. So truth table, how the truth table is there, based on the truth table only we will be able to draw the characteristic table. So this is truth table of SR flip-flop, and next we need to draw the characteristics table. So to draw the characteristic table, we need to draw the table in which there will be the inputs. So what will be the inputs? Inputs will be the input of the flip-flop and the current state. So input of the flip-flop is S and R. So S and R will be the input, and the current state, that is Qn. Qn is the current state. So these three will be the input, and the output will be the next state, n plus 1. So if three inputs are there, so possible combinations of three inputs will be 0, 0, 0, then 0, 0, 1, 0, 1, 0, 0, 1, 1, then 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1. So this is how the inputs will be represented into the characteristic table. Now we need to find out, like, if this is the input, if this is the current state, and this is the input SR, what will be the next state? So that we can take the next state with respect to the truth table. So you can just see, so once we are having the S and R, here S and R are given to be like Qn, that is the current state. Whatever the current state value is there, it will be holding it together. It will be holding it. So next state value will be the same value, that is the current value. So current value is Qn is equals to n, Qn is equals to 0. So Qn plus 1 will be the same value, it is 0. If it is 1, it will be 1. So this indicates the hold mode of the flip-flop. Next combination of input is this one. So here S and R in both the cases are 0 and 1. So we can just see for S and R 0 and 1 output, that is Qn is 0. So whatever is the Qn value is there, either 0 or 1, but Qn plus 1 will be 0 only when S and R are 0 and 1. So here the output will be 0, 0. This output is 0, 0. It is considered to be the reset mode. Now the flip-flop is working in reset. Next is the condition where S and R is 1 and 0. So for 1 and 0, Qn plus 1 is 1. Qn plus 1 irrespective of the current state. So current state is 0 and 1 for these cases, but irrespective of the current state, the output will be 1 only. So here the output will be 1. So this output is 1 is basically considered to be like the set mode. So now we say like that this flip-flop is working in set mode into this category. Next one is the case where S and R are 1, 1. So if it is 1, 1, the output is invalid. So output is invalid. What is its meaning? Invalid in the sense it can be either 0 or 1. Okay, so it is an invalid. So we will be calling it out the don't care in case of characteristic table. So we will be representing it with don't care. So with the help of characteristic table, we need to draw the characteristic equation. Means how the next state is related with respect to S, R and Qn. So for that we need to draw the K-map. So we need to do the K-map simplification here. So we know that already. So if this is the truth table for a particular function, this is a one function. So wherever there is a 1, with respect to that we will be finding it out the mean terms and we will be putting it into the K-map to simplify it. So we want to get an equation for the Qn plus 1. So for that we will be drawing the K-map and simplifying it for different input conditions. So here suppose we have taken S and here R and Q. So it is S bar and S. This is R bar, this is N bar, R bar Q, R Q N, R Q N bar. So I hope it is clear to everyone. So wherever there is a 1, we will be taking that as a mean term, and this is X, that is considered as don't care. So we will be considering it as a don't care also. So whenever there is a 1, it is 0, 0, 1. So it is mean term 1. This is 1, so this is 1, 0, 0. This is mean term 4. This is 1, so it is 1, 0, 1. That is mean term 5. And these two cases are don't care conditions. So it is 6 and 7. So for 6 and 7, it will be having the don't care. Now we need to simplify it. For simplifying, we need to do the pairing. So once we will doing the pairing, it will be like 4 quad pairing will be like 1 quad pairing, and the next will be 1 pair. So with respect to this relation, we can find it out. So for Qn plus 1, the expression will be like here S, and for this it will be R bar Qn. So this is our characteristic table, characteristic equation for SR. So I hope you are getting the point, like how this complete system is being implemented. So for SR flip-flop, with respect to the table, we have drawn the characteristic table. With respect to characteristic table, we can find out the characteristic equation. So for JK flip-flop. Now the same we need to find out what is the characteristic table and excitation table. In the truth table of JK flip-flop, there is a minor difference. So what is the difference? Difference is basically here. So whenever there is a 1-1, it will be working in toggling mode. Toggling mode in the sense it will be having output as complement of the current state. So Qn is the current state, then Qn plus 1, Qn plus 1, that is the next state, will be the toggling of the previous state, that is the current state Q1. And the remaining things will be like here, it is Jk, so it will be J and K. So this is the truth table for Jk. And similarly, in case of characteristic table, we will be changing here, it will be J and K. And with respect to that, what will be the characteristic table, we will be just drawing it out. So it will be similar to that only. So what is the difference? We will be just drawing it out. So this is the truth table for JK. So characteristic table of JK flip-flop is this. So similar to the SR only, it will be there. So for 0 0, it will be 0 1, and it will be hold state, then reset, and then set. The only difference will be the 1 1. When 1 1 is there, when J and K is 1 1, it will be toggling. Toggling will be there in the sense, if 1 1 is there, whatever is the current state, the next state will be toggling of this. So once we do the toggling, it means it's complement. So if it is 0, it will be 1 here. Here it is 1, it will be 0. So this indicates toggling. Toggle mode of JK flip-flop. So once we have the characteristic table, now we will be going for finding out characteristic equation. So in the characteristic equation, we will be basically considering the ones here. So wherever there is a 1, we will be taking it out, and then we will be putting it into the K map. So it is 1, then 4, then 5, and then this 1 is with respect to the 6. So this is the 6. So this is basically J. So it is J bar, J, and K and Q n. So it is K bar, Q n bar, K bar Q, and K Q n, K Q n bar. So for doing the pairing, you can just see. So because this one can be paired with only this one, and these two can be paired together. So finally, if we write it down the equation for Qn plus 1 here, so that is going to give like this is J multiplied by common between these two is Qn bar plus here it is K bar Q. So this will be the characteristic equation of JK flip-flop. In SR flip-flop, we have gone through. So in SR flip-flop, we will be drawing like how we can draw the excitation table also, because characteristic equation we have just gone through, then excitation table. So how the excitation table is basically drawn. So we will be also looking at like what is the excitation table. So excitation table gives the relation like the inputs will be behaving like output, and outputs will be behaving like an input. So here the excitation table will be in relation with the Qn, that is the current state, and then Qn plus 1, that is the next state. These two will be the input, and output will be, if it is SR, output will be S and R. Two different outputs will be there, and inputs will be Qn and Qn plus 1. This is basically gives the relation between the inputs and outputs. So input will be going to be dependent on Q1 and Q1 plus 1. So it is 0 0. Two inputs are there, so combinations will be 0 0, 0 1, 1 0, 1 1. So with respect to the truth table or with respect to the excitation table, you can get that, like how we can find it out the values. So here you can just see if we are talking about here. So Qn is 0 and Qn plus 1 is 0. So what will be the input case when Qn and Qn plus 1 will be 0 and 0? Means there is no change. That means there is a hold condition. So hold condition we know here. So here is the input. With respect to this characteristic table, you can see if previous state or the current state is 0, next state is 0. So this is the case where S and R are equals to 0 0. So the first is the case S and R, where S and R should be 0 0, then only the current state will change to 0 itself. This is there. Next is again here S is 0 and R is 1. If S is 0, R is 1, then also the same case will be there. Qn is equals to 0 and Qn plus 1 is 0. And there is no other case. There are don't care, we will not be considering that. Okay. Because even if we consider it here, it is coming out to be 1 and 1 and 1. So if it is coming out to be 1 and 1, we will not be basically, but because we need to find it out, the condition, one condition for S and R, so that this condition should be satisfied. So for that, this was the case. So here S is 0 and R is 0 and 1. So we can write it down X, in the sense R is any value. If S is equals to 0, then it will be having the condition. So here S will be 0 and R will be 1. Similarly, we will be finding it out the case like how the relation between Qn and Qn plus 1 is there, such that Qn is 0, the current state is 0 and the next state is 1. So how it is related? So again we will be looking it out by using the truth table itself, the characteristic table itself. So we will be looking at now Qn should be 0, but the Qn plus 1 should be 1. So this is 0 0, this is 0 and 1. So this is the case where S is 1, R is 0. So S is 1, R is 0. S is 1, R is 0. This is the first case. And no other case is there, that is don't care, so we will not be considered because the invalid case was there, so we will not be considered. So only S is 1 and R is 0. So here S is 1, R is 0. So when S is 1, R is 0, at that time current state will change to 1 in the next state. Next we will be looking like Qn is equals to 1 and Qn plus 1 is 0. Qn is equals to 1 and Qn plus 1 is 0. Yeah, 1 and 0. So here it is 1 and it is 1, 1 and 0. This is the case where S and R is 0 and 1. And no other case is there. So here it will be S is equals to 0 and R is equals to 1. S is equals to 0 and R is equals to 1. Similarly for 1 and 1 means Qn and Qn plus 1 should be 1 and 1. So this is the case like where S and R are 0 0 or S and R are 1 and 0. So S R is either 0 0 or 1 and 0. So in that case R is equals to same 0 is there and S is 0 and 1. So for any value of S, R is 0. In that case the value will be 1 and 1. So here it will be don't care and then 0. Okay, don't care and 0 because 1 1 and 1 1 is coming out to be here. So it is don't care and 0. So this is how the excitation table is drawn for a particular flip flop. So with the help of characteristic table we can draw it, and with the help of excitation table basically it gives like this is the different states of the flip flop. So flip flops state are like next state is either 0 or 1, 0 or 1 next state. So these states can be are framed together, that these states can be combined together with respect to inputs, and that is done by using the state diagram. So there is a term state diagram. So how we can draw the state diagram? So state diagram will be providing a flow diagram or block diagram that will be indicating like what is the relation between different states and what is their respective inputs. So here two different states are there, 0 and 1 for the output. So two different states. So one state will be represented by 0 inside a circle. Another state will be represented by a circle inside a circle is there, and inside that the value of that state is 1. So state is 0, state is 1. So flip flops output is either 0 or 1. So two states are there. Okay. So now you can just see Qn is 0 and Qn plus 1 is 0. Means from current state to next state, if there is a change, if it is changing from 0 to 0 itself, at that time S and R should be 0 and don't care. Its meaning is like if this is the state, and after changing the input, the state is changing to same, means it remains the same. At that time the input condition should be S should be 0 and R should be 2 here. So this is the condition of the input such that the state will be same. Similarly, suppose state is 0 and now the next state is 1. If the next state is 1, then what will be the input condition? So here if the next state is 1 after 0, so it is the input condition should be S should be 1 and R should be 0. Similarly, the flip flop is at one state and it changes to 0 state. So if it is changing to 0 state, from 1 state it's changing to 0 state, then what is the condition for input is S should be 0 and R should be 1. And if the state is 1 and it changes after changing the input, the state is again 1 only. So in that case it is possible when it is remaining at the same state, when the input condition should be S is equals to don't care and R should be 0. So this representation of the different states in the sense next state, okay, or the states of the flip flop with respect to their respective input conditions is basically considered as the state diagram. This is the state diagram in case of the SR flip flop. The same we will be looking here also, like in case of JK flip flop, the characteristic equation we have gone through. Next we will be looking at as the excitation table. So in excitation table, in case of JK flip flop also, it will be similar. So Qn and Qn plus 1 will be the two inputs, and output will be J and K. J and K will be the output. So four possible combinations of the input conditions is 0, 0, 0, 1, 1, 0 and 1. So when in current state and next state is 0 and 1, 0 and 0, that means there is no state change. So you can just see here. So if it is 0 and 0, at that time what is the J and K value? We have to just find it out. So this is the first case, like where previous state and next state both are same or both are 0, 0. This is the first case. Second case is this one, and no other possible case is there. So JK is 0, 0 or 0, 1. So JK is 0, 0 or 0, 1 in the sense K is changing from K has been two different values 0 and 1, but J is same. It's meaning J will be 0 here, J will be 0, but K will be don't care. Similarly, for Qn is equals to 0 and Qn plus 1 is 1. So 0 and 1. 0 and 1 is here. So at this position, the current state is 0 and the next state is 1. So it is J and K is 1 and 0. Next is this one, where J is 1 and K is 1. So K is 1 and 0, but J is same 1. So it will be like J will be 1 and K will be 2 here. Similarly for 1, 0, for 1, 0, this is 1, 0, this is 0 and 1, and then 1, 0 is there. So 0, 1 and 1 1. K is 1, J is 0 and 1 means J is changing, or J has two different values, so that's why we will be putting don't care, and K remains the same, that is 1. Next is for 1 1, so current state and next state both are 1 1, that is J and K should be 0 0, or J is 1 and K is 0. So K is 0 but J is don't care. J is don't care and K is 0. So this is the excitation table for the JK flip flop. Similarly, with respect to the excitation table, we will be finding out the state diagram. So state diagram again here, the next state is having two different values, either 0 or 1. So the outputs are represented inside a circle as a two different states, because two different values are possible for the output. Okay, so inside a circle we will be putting these values, that is the state we will be considering as a flip flop state, and then we will be looking it out like if the state change or no change is there, at that time what is the condition of the input. So here Qn is at suppose 0 state and it is changing to again 0 only, means there is no change. If there is no change, at that time J and K conditions will be 0 and don't care. So from 0 to 0 itself, the J should be 0 and K should be don't care. From 0 to 1 there is a change. Okay, if state is changing from 0 to 1, at that time the input condition should be J is equals to 1 and K should be don't care. Similarly, from 1 to 0 it is changing, at that time the input condition will be don't care and 1. So J should be don't care and K should be 1. And for 1 and 1 means from 1 to state changes, again after changing it is again remaining 1 only. At that case the J should be don't care, J should be don't care and K should be 0. So this is basically the state diagram in case of JK. So next we will be looking at a D flip flop. So for D flip flop, we will be looking at what is the truth table. We have already gone through that. Truth table will be like here. We will only be considering, we are not considering the clock here, because by default we are considering like the clock is always 1 once the flip flop is working. So D is the input, okay, and the output is Qn plus 1. So if D is 0, the output is 0. D is 1, output is 1. That's why D flip flop is considered to be the transparent flip flop. So this will be the case of the truth table. Similarly, we will be finding it out the characteristic table. So what is the characteristic table? So in the characteristic table, there will be, first of all, there will be D, that is one input, and the other input will be the Qn, that is the current state, and the output will be the next state, that is Qn plus 1. So these would be two inputs are there, so possible combinations will be 0 0, 0 1, 1 0, and 1. So now here, with respect to these, what will be the output we need to find out here. So once we see here, so if D is equals to 0, output will be 0. Q next state will be 0 only. So either Q is 0 or 1. So we can just see it here. If D is 0, output will be 0 only with respect to the D only. Either Q, that is previous or current state, is 0 or 1, that is having no effect. If D is 0, the next state will be 0. Next is here, if D is equals to 1, so irrespective of the current state, the output will be 1 only. So I hope you are getting the point here. So from here we have calculated. Now we need to draw the K map to simplify the expression for the Qn plus 1, that will be giving out the characteristic equation. Okay, in case of D flip flop, so here because two inputs are there, or two variables are there, so possible combinations like 0 1 2 and 3. So here mean terms, to write down the expression we will be finding out like 1, there is 1, with respect that it is 3 and 4, so 2 and 3, so 2 and the mean term 2 and 3, mean term 2 and mean term 3. So once we do the pairing, it will be coming out over here. So once we do the pairing, then the expression for qn plus 1 will be, so this is basically the d bar and d. So this is coming out to be d, and it will be coming out to be 1. Total values we have taken, total midterms we have taken. So adding these two will be coming out to be 1. So the characteristic, this is the characteristic equation of d flip flop. We will be drawing is the excitation table. So in excitation table, we will be having two different inputs. One will be the current state, another will be the next state, and the output will be the input. So for D flip flop, input is D, so D will be the output. So now we will be drawing it together. So 0 0 0 1 1 0 1 1. This is the condition for possible conditions of Qn and Qn plus 1. So if here Qn is 0 and Qn plus 1 is 0, so the D will be 0, means because here D will be with respect to the Qn plus 1 only, value 1. So if Qn plus 1 is 0, it will be 0. It is 1, so it will be 1. It is 0, so it will be 0. It is 1, so it will be 1. You can just check it out from this table also, the characteristic table also. It is coming to be same only. So this is the excitation table. So once we have the excitation table, we can draw the state table also, state diagram. So if we are drawing the state diagram, so Qn plus 1 is having two different states, 0 and 1. So one state will be written here, another state is 1. So once it is changing from 0 to 0 itself, at that time D value is 0. So D value is 0. When it is changing from 0 to 1, it is changing from 0 to 1. At that time the D value is 1. When again it is changing from 1 to 0 state, so 1 to 0 state it is changing, at that time D is equals to 0. D should be 0. Again when it is changing from 1 to 1 itself, at that time the D value should be 1. So this is the state diagram in case of D flip. Next one is the T flip flop. So T flip flop, for the T flip flop truth table, first of all we will be finding it out what is the truth table. So truth table in case of T flip flop is T is the input and the output is the next state. So T is 0, output will be Qn, that is the current state is the output. When Q is equals to 1, the output will be complement of the current state. So if this is the case, we need to draw the characteristic equation. So in the characteristic equation, it gives the relation between the input, first of all, input that is T, and then Qn. Qn will be the current state, so it will be part of the input, and the output will be Qn plus 1. So two inputs are there, so possible combination 0 0 0 1 1 0 1. So when T is equals to 0, whatever is the Qn value, the same will be the Qn plus 1 also from here. So it will be holding the same value. So if T is equal to 0, it will be holding the same value of the, this is the current state, next state will be having the same value. Here also it will be having same value. So whenever it is having 0, so whenever it is having 0, it will be having the same value, holding the same value. Whenever it is having 1, it will be doing the complement. So complement in the sense current value is 0, so the next value will be 1. If current value is 1, next value will be 0. By using the characteristic table, we will be using the K map to simplify its expression. So it is 0, 1, 2, 3. So wherever there is a 1 at this location, this will get 1 and 2. So 1, min term 1 and min term 2. So with respect to that, we can just find it out like there is no possible pairing is possible. So we will be circling it separately, and then we will be writing down the equation for the characteristic equation of the T flip flop, the Q n plus 1 for T flip flop. This is coming out to be like T bar and T. So this is T multiplied by T multiplied by this will be the Q n bar. Qn bar. Next one is, this is T bar multiplied by Qn. So this will be the characteristic equation of T flip. Next we will be looking is the excitation table. So excitation table is having the relation between the inputs. So inputs will be Qn and Qn plus 1. These two inputs will be there and output will be the T. So it is 0 0 0 1 1 0 1 1. So when the states are same, means it is holding the value, so T should be 0. If it is again like previous state was 0, next state is complement of the previous state. That meaning T should be 1. Here also, whatever there is a complement. So previous state was 1 and the next state is 0. So there is a complement, so T should be 1. Both are having same values, so it is holding the same value, so T should be 0. I hope you are getting this. With respect to the excitation table, we will be drawing the state diagram. So what is the state diagram? So again there is two states only, so 0 state and 1 state. So from 0 to 0, for going from 0 to 0, T is equals to 1. T is equals to 1. So T is equals to 0. Again from going T is Qn is equals to 0 to next state is 1, and then again from 1 to 0, and then from again 1 to 1. So we need to find out what is the value of T. So if Qn is going from 0 to next state, that is 1, at that time T should be 1. And again if it is changing from 1 to 0, 1 to 0, T value should be 1. If it is remaining at the same state, T value should be 0. This is the basic idea about the different flip-flops and their characteristic table and the excitation.